Does not have to be integer. It can be, since it's a numeric acid, it can be 8.345, and that will get in there. That's then easy. 12 means all the observations just greater than 12, less than equal to 60. Now let me tell you how the frequency. So between 4 to 8. 1, 2, 3, 4, 5, 6. 4 to 8, all of them there. So it's 6. The next one starts more than 6, but go up to 12. 9, 10, 11, 12, 4. Then more than 12, up to 16. 14, 16, 16, influence of 16. More than 16, 20. 17, 17, 3, 4, 5, 6, 7, 8, 9. Up to all of them. 20 to 24. 1, 2, 3, 4, 5. Then 24 to 28. 25, 28 is 3. And then you add them, it's 30. No. How much is that? Yeah, it is 30, right? Okay. So first it was 28 with the number 30, and it's 30, that's right. And then you know how to do it. So from here onwards, everything was fine. We could do divide by 30, we were finding points. But putting the frequency buckets are very important. Take it from here, and this will be same as you can do with Excel. So you can have a verification. You can verify and say, yeah, I did kind of Excel. But many book has a little different way of dealing. They have a little different diagrams, but we follow this. So it works fine. All right, I think that's all we have. Then let's see what's more. Roadmap to day. This is the one we have not done, the empirical rule. This is on frequency and histogram, it's not on probability. Probability. Three approaches. So, not looking here anymore. Three approaches.
Three approaches.
In general, this is the three ways you can attack a problem and find the problem. One looks at the structure, and looks at the frequency, other is looking at the expert opinion, and we'll discuss how that works. When we know this you can find the event probability. But then we can combine events. And finding probability of the combined events is also a difficult task. So we work on combination of events probability rules. How do you combine the events and how do you get the probability? There are some probability rules. So let me see how much we can cover. So first it starts with the empirical rule. So remember when I drew three histograms and showed you where the mean, median, mode will fall, which is called its structural property. This is also a structural property, the empirical rule. Empirical data means data we found out from experiments. This is a statistical jargon we use it. The data you find from statistical experiments are empirical data. The empirical rule is, suppose you have a histogram and that is very nicely behaved, which is nearly symmetric. It doesn't have to be completely, nearly symmetric. If that happens, we know that mean equal to median equal to mode.
What is that last word you say? The 3 and I can't really read.
Which one?
The first blue line.
Three approaches.
Approaches.
Okay. So if you have a fairly symmetric distribution, this is fairly symmetric. Though I am using the word fairly, the reason is we will actually deal with the actual complete symmetric distribution called normal distribution. Then you will learn how to get the data from there. But right now we are drawing some distributions and it looks like this. Frequency histogram is like this. So there are some statistical properties. So this is the mean, or x bar is also same, since usually we'll deal with a small number of data. And what is on this x-axis? This axis is x. Always remember that this axis is the frequency of the occurrence of x. If your x bar is 50, that means 50 happened this many times. More than 50 going that way, less than 50 that way, less than 50 happening lesser times, more than 50 happening lesser times. So that's the way the plotted. Do you remember that, right? So it says when you have x bar and you go up to 1 standard deviation, 2 standard deviation, 3 standard deviation. And we will do that with a real number. So if you are kind of looking the numbers around your mean, which is 1 standard deviation, if you are looking at x plus minus plus 1s and minus 1s, the area under the curve, and yeah, let me tell you what does it really mean. Is 68% of the whole population. The area under the curve is 100% of the population, that's the frequency. Everything is inside there. Your mean is 50. And you go to 55, suppose the S is 5. So between 45 to 55, if you look at the data points, your values, 60.8% of the data should be there. Two is when you are venturing two times standard deviation on the back and forward, you cover 95% of the data. Most of the data, all the data values should be covered by the values mean plus minus. This one's better. Let's use x bar plus minus 1 times s standard deviation covered 68% of data. And this is pretty strong observation, irrespective of what your mean and standard deviation is. I said mean 50 and standard deviation 55, you can do that. It can be anything. Mean is 500 and standard deviation is 0.1. Still the same thing will be valid. So that's a structural property, irrespective of the actual numbers. This will hold. X bar plus minus 2 times standard deviation, I will do the problem so you can understand, covers 95% of the data. And when you do x bar plus minus 3 sigma, it nearly covers everything. That means most of the data points should be covered by this. Covers 99.7, some book writes 100% of data. Know this and I will kind of do a problem and we'll see exactly what it means. Okay? That's the point of symmetry, and unless you have a fairly symmetric, you will not be able to draw this conclusion. So if you draw your histogram and it looks like it's symmetric, then this is structural property, you can use it right away, and we will show you how you can use it.
And then the 1 standard deviation, 2 standard deviation, you said 3 sigma. Is that the same? Is that the
Standard
same?
deviation. You are right. That should be yes. Remember, if I see mean should be sigma, if I say mu, then sigma, x for whatever. Thank you. Have you guys heard about Six Sigma belts? There is a course called Six Sigma belts. Means you will learn all about quality control. So there they say that you are a manufacturing company, you are manufacturing something to the specification. Suppose you want maybe the diameter of a fan. So this is the diameter of a fan, x equal to 25 inches, big fan. And the diameter can vary between plus minus 3 sigma. That means if your production is between this, you are still in control. More than that, you are out of control. That's called plus minus 3 sigma or 6 sigma chart. So they all come from here. Okay, here you see a problem. Say a large vector class a large vector class with 20 students with 280 students. test score, mean test score of 74 and standard deviation of 8. Deviation of 8. The distribution of scores is fairly symmetric. That's the ambiguity. So if that is the case, let me tell you what does it mean. It means if you draw the frequency distribution of all the marks scores that 280 students got, you draw a histogram. There you have all the numbers, draw a histogram. We know exactly how to do it. We found out number of classes, weight of the classes. Do the same thing. And after doing it, it looks like pretty symmetric. So this one says the mean what they got is 74. %, means how much? 68% of 280. Let's get those numbers right. How much it was? 280 into 0.68. That's the total. 190. And I will tie it back and tell you what it is. See, we know that 95% covers some things. What is 95% of 280 means what? I'm saying 190 students, 266 students, and 99.7% of 280 is nearly 280. 100% students. And they are saying X bar plus minus 1s, that's equal to 74 plus 8, 74 minus 8, 82 and 66. Now just looking at that two values, you can say out of 280 people, between 66 and 82, I know 190 of them got that. That's exactly the same. X bar plus minus 1 sigma covers 68% of the data. That means when the value is score is between 66 to 82, I cover 190 of the students out of 280. So to draw it, it looks like so it's 74 plus 8, right? 82. So when your X is 82 and 66, which means 190 students are already here. Out of 280, 190 are already here. When you say x bar plus minus 2s, that is x bar plus 2 times 8, 16, 90. X bar, sorry, 74 minus 2 times 8 is 58. So in the scores, if you look at the scores and find how many are gotten between 58 to 90, you will find 266 of them got. Most of the students already got that value. 90, when x is 90 that way, and x is 58, this is 0 plus minus. X bar plus minus 2 sigma, if you will, or 2s. This area is 95% of the whole area of the big graph itself. And if you have the frequency, if you add them up, you will see 266 people already covered there. And then between this and this, last one, everybody is covered. That means the lowest they got it. X bar plus minus 3 sigma, 3s, 74 plus 3 times 8 is the highest of the class was 98, 74 minus 3 times 8, 50 is the lowest. So you can see that in the whole gamut, between 50 to 98, everything that you have got it. And you can see that's all been covered by this itself. It says 99, all students are covered. So once you get something like this, we'll ask you some questions and see if you can answer.
Excuse me, Professor.
Yeah.
Your second line, is that 74 plus?
Which one?
2 times 8 or 2
2
plus
times 8.
2 times 8?
2 times s, right?
Yes.
S is 8.
Okay.
So 2 times 8.
And then, so back to that, how did you, okay,
That's
standard deviation, okay, deviation of it.
right.
No problem.
And those values will be given to you. And what I'm trying to tell you, if this mean is 5074 and standard deviation is 25, still this will hold. You will look at this number and say, oh, 98% is within this, 68% is within this. So that's the structural property. It does not depend on the value itself, but it depends on the property itself. Okay? Easy questions and then simple questions. Question 1 was, suppose somebody, you have these numbers, the scores. Question is, approximately how many students score within 58 and 90. Suppose this was the question. What is the answer? They said find out this gap what is being covered? It's 266, easy. So if you have those three numbers, we got those things out, right? 66% or 50%, 190, 266, and 99. Okay, that's easy. Question number 2. How many students got between 74 and 82? How do you find that? Scored between 74 and 82. How do you find it? And those numbers are not there. But you have everything in this chart. I said, I want to find out number of students scored between 74 and 82. That means I'm interested between 74 and 82. All the students, they fall here. But I don't know how much is that. That's right. Between 74 and 82, 74 and 90, and 74 and this, we move the graph like that. But I said, between 66 to 82, we have 68% of the people. I know 190 of them are inside. So that is the part of symmetry. That means the number of students more than 74 is same as number of students less than 74 in this area. So in here it says 66 to 74 and 74 to 82. That's all the area I have and all the students I have. That's equal to 160, right? 190. So from 68 to 74 is half of that. So 190 over 2 is 95. 190 over 2, 95. So now you can say between 74 and 82 is 95 students. Since you can immediately talk about the symmetry, and the symmetry means divided. So remember this, how much is this area? Any clue? How many percent is this? If the whole thing is 100%, how many percent is this one? Roughly 50%, right? This is 50%, this is 50%. And what they're saying, between 74 to 98, half of the data points are there. Between 74 to 58, half of the students are there. That's all it is. Now I will ask you some other question. Question is question number 3. So try to think and see, oh, this is 50%. This is, whole thing is 68%. That means this is 34%, this is 34%. So if you can see it is 50%, it is 34%. So I know how many percent are these. So that all calculation you have to do. Okay, number 3. How many you may want to know in this is the class distribution given. How many students got A? And A is 90 plus. Did you find it? If you find it, you got an A and you clear the test. How many students got an A? An A means 90 plus, inclusive 90 plus. How do you find it?
Subtract 95% from 100% and divide by 2.
Excellent. That's exactly true. So what he is saying if I cover all the guys who got from 50 to 90, all of them covers 95% of all students. 266 students got between 95, 58 to 90. So there are a small number of students got less than 58 and more than 90. And that percentage is 100% minus 95%. Since this is equal to 95%. So if I say 5% of the school students, I have them, some are very low, some are very high. And symmetry means half and half.
So do I get an A on the exam?
You can skip it. No. But yeah, that's very good. I will keep that in mind.
Can you explain that again?
Yeah, definitely. See, always think this graph as 100%. Everything is here. And I said, in the bottom is the scores. Scores, how many they have gotten, and you plotted them, right? This is the graph. And we found out from this math and everything, between 50 to 98, sorry, 58, yeah, 50 to 90, this one, 58 to 90. 95% of the students fall in there. That means this area on the chart is 95%. That means out of 280, 266 is got between 58 and 90. That means some got more than 90 in total 280. Some got less than 58, but you do not know how many are there. And how many percentage are there from the whole thing? The whole thing is 100%. They are on the last part, and they are not in 95%. This is 95% of the graph.
So it's 5.
It's 5, and this is a symmetry means half and half.
So that's 2.5.
2.5%. What is it now? Who got 9? Yeah, it's 2.5% times 280. Yeah, see how many are there. So try to understand. Students score between 58 to 90 is 95%, and that's equal to 266. So students score less than 58 or greater than equal to 90 is 5%. Is 100 minus 95 is 5%. Since 95% is already covering 58 to 90. People who are below 58 and above 90 are only 5%. And for symmetry, it is 2.5%. So for symmetry, students got A. Is 2.5%. That means 280 into 0.025. How much is that? 7. So 7 students got more than 90, 7 got less than 58, and the other side. So this is from the structure property And when we will learn normal distribution, with the actual formula, we will see all these things fall into place very easily. You can see why it is coming. Okay, I think we are done with that.
And is this all part of the empirical rule?
Yeah.
You say this is structured properly?
Right. Structural property is empirical. That's the empirical. You remember there are three other properties I showed. When mean is greater than median, greater than mode. Mean is less than median, less than mode. In this case, one more time, it's 68%, 95%, and then 7%. Okay. Now, three approaches I think we have differentiate. Right. Okay. So who remembers the definition of probability? What was that? Probability is a numerical measure, it's a number, which tells you what is the chance of occurrence of an event. An event occurrence is happening. I cannot tell you exactly what will happen, but we can give you an idea of what will happen. And that's the probability. So if that is the case, there are three ways to attack the problem. You can do, there are three approaches. One is classical, other is frequency, and last one is your subjective opinion. Three approaches to find probability. And here your objective is to get the actual number. You got to get the actual number. When we will say probability rules and events, those are all mathematics.
Approaches to
Here
find
you are trying to find out the actual numerical measure. Three approaches. One is classical approach. Number two is empirical or frequency approach. This is, you already have seen this one. We have been working on this for a long time. And number three is subjective. When you cannot do this, you cannot do this, then you try to do this. So let's start with classical approach. Classical approach is, it's usually a small set of problems, not too many can be solved by this. It's very structure driven, means you can look at the structure and you should be able to kind of find out what's going on. Just like you are tossing a coin. You know that whether it will be head or tail, and that's all it can happen. Now I can say toss two points at the same time. Now the sample space, that means what outcome will be a little more. It can be head and head or tail or head, tail or tail. So still there is a structure, and you can say those without doing any experiment. So classical methods are usually small number, Classical approach. Highly structured problem. Highly structured problem, then a small number of problems can be solved. You can see it is maybe gambling or some places where you have 52 cards and that's all you have, or 2 dice. But in real life, most of the data are empirical or physical, so you're not going to do that. A small number of problems can be solved. But the most important is this one. Every outcome of the experiment, we will always have to have an experiment, right? Statistical experiment. Is equally likely toss a coin. Probability of a head is a half, probability of tail is a half. If it's a biased coin, go ahead.
That's the last word on the highly structured.
Highly structured problems. Problems.
Thank you.
Sure. Every outcome of the experiment is equally likely. If you have 6 outcomes, every one is 1/6. If you have a 6-faced die, you toss it, it can be 1, it can be 2, 3, up to 6. Out of 6, one thing will happen, so every possibility is 1/6. But if you have a die which is biased die, and you get 2 falls more often than 1, and 3 often less, then you will not be able to solve it this way, then you have to do something else. So as long as the equally likely condition is valid, you can use it. And this one you get a word. The outcomes need to be mutually exclusive. You run the experiment, you know the structure, the outcomes, 2 of them cannot be same. If the outcome is head, it cannot be tail. The outcome is 1 out of the die, it's not 6. So every outcome is mutually exclusive. All the outcomes together not connected to each other at all. And the outcomes are collectively exhaustive. That means everything has to be covered. Then you should be able to find the probability. The outcomes are collectively exhaustive. That means all the outcomes you have looked at. There is not something we missed it. If you miss something, some probability will be out there, you will not go to get it. So this is the fundamental law of probabilities, applicable to all three. Fundamental rule. You've seen that before. Putting it in a mathematical form. Probability of an event has to be greater than 0, less than equal to 1. As we said, probability of 477 will not make any sense. You have to put that in the boundary 0 to 1. number 2, sum of the probabilities of all the outcomes. See, you have found out mutually exclusive outcome, connected to roasting, and you got all of them. You find out each and every one's probability, add them up, it must have to be 1. The sum of all the probabilities of the outcomes must sum to 1. Let's see on the test. So you have probability of an event, you have a whole bunch of events, the outcomes are n outcomes. It says probability of every outcome, when outcome goes from 1 to n, must be added to 1. This is just a fancy way of writing, but when you add them up, that must be. Let's see the real probability. Classical method. So a student takes a pop quiz that consists of 3 true-false questions. True, false questions. So first question is, what is the experiment? Experiment is the student is taking a quiz. That is the experiment. Since you can take the quiz, but you do not know how much you got. But you know something you will get. That's what you said. An event or an experiment is the outcome you do not know, but you have an idea. And I can give you some probability of it. So here the experiment is taking quiz. The question is, find the sample space of the experiment. What does it mean? We will find probability after that. The question is, find the sample space of the experiment. What is that? What are they looking for? So they are looking for all the outcomes that can happen. You have took the test. You might have passed, you might have failed, you might have got all of them correct, you might have done some correct, some wrong. So all of them together are outcomes, and they are saying find the sample space means all the outcomes that can happen from the experiment. That should be defined, right? Sample space is all the outcomes. All outcomes of an experiment. So how do you find the sample space? It is more hard. So you have to define an event. You have to define the probabilities or the outcomes, and then you have to find it. So the way we will do it, since it's a classical method and it's pretty structured, so we'll see what can be the sample space. So I will even define event C, which is student answered correctly. That's all it can happen. But there are two options, it can be correct or incorrect. And what you are trying to do is you're looking at question number 1. It's looking at question number 1. The event can be C or the event can be I. That means you either correct or wrong. And that's the way you will develop the whole sample space. Event I is student answered incorrectly. That's all you can have. So again, told you, probability is not like algebra, probability is not like geometry, which you did. It's very difficult, not difficult, it's different. You have to think through it. So I will define the sample space this way. So the outcomes, right? So let's see. Any one of them will happen, but all can happen is question 1, question 2, question 3. What option may be? He is correct in the first question. Second question is also correct. The last one is incorrect. That can be an outcome, right? But I do not know whether that will happen or not, but there's a chance. Another can be correct, but the second was incorrect. Last was correct. Right? Then I had the first one is correct, incorrect, incorrect. And then he will have, possibly he is lucky enough, he got all correct. There is a nifty formula to find out how many of them will happen. I won't tell you, but that's not coming chest. Or the first one was incorrect, the second one was correct, third one was correct. The first one was incorrect, second one was correct, third one was incorrect. First one is incorrect, second one is incorrect, third one is correct. Or all. Can you find another which we missed it or anything? Can there be 9th outcome? Why should I stop at 8? I said it should be, these are mutually exclusive. You can say none of the outcomes are same or are different. And I'm saying it has to be collectively exhaustive, means there should not be anything left. How do you know that you can play? So the nifty formula is when you have these true, false, yes, no outcomes like that, when there are 2 outcomes, it is 2 to the power n, where n is the number of options or number of questions you are addressing, number of questions, number of bids you are doing, number of jobs you are applying for. 2 to the power 3, since we have 3 questions here, is 8. So it should be fine. So 8 things can happen. All are equally likely. So what is the probability of any one? 1/8. Probability of CCI is 1/8. Probability of any one you pick is 1/8, since that's called first or one of our conditions, right? Now let's go over the questions. So question, probability the students get all correct. Student gets all correct. Which one? When you get this, you try to find out from your sample space. That means he's looking for all outcomes are correct. That's only happened one time, right? So that's easy. Question number 2. Or one answer, I should say. Right? How do you find that? How do you find that?
Just count the occurrences.
So it says you find the outcomes where only one, exactly one answer is incorrect. How many of them are there?
8.
Hmm?
Sorry, what?
It says find out from the outcomes, take the outcome which has got only one incorrect. Which one?
There are like 4.
4? Only one incorrect.
Yeah.
It's 2.
I know this is the one,
1.
only one incorrect. This is the one, only one
And then
incorrect.
there's that
3.
3
Oh.
And I think not anything else. So the probability is number of outcomes in favor of your whatever the event is by total number of, right? That's the initial definition. Here you have this probability of CCI. That event you have CIC and ICC. This covers your everything, the whole event, which is subset of the outcomes. And that is 3/8. And this I came from using the definition of probability. Number of outcomes divided by total number of. And question number 3 is probability. 2 questions are correct. Questions. So what is your sample space here? Which one you consider? At least 2 questions are correct. This is definitely comes in, right? The same CCI or how many of you getting? 4. Yeah. CIC. CCCC, that's also, since at least it said, that means if you have 2 or more, you should be alright. And
2
then
questions are
ICC. So there are 4 events. So for structural one, try to find out the sample space right away. If you can find out the whole sample space, you can find all the outcomes. The good part is each outcome is equally likely, so you can just mix and match. So I will do one more real quick. As frequency, you guys know all about it. We are talking about frequency for so many times. The relative frequency are the probabilities. If you add them up, they are cumulative. Now you figure it. So one is done. Second one is frequency, it's already taken care of. The last one is subjective. I'm going to tell you, at least quickly give you the problem, and you will see. It's much easier. Bid for the position. Oh, they are choosing for CIU. 4 candidates bid for the position, and the following are the a priori probabilities, which you know prior hand, of being selected as the CIU. Selection. Four candidates. These are all gone, so I need to get some more. Wait for the position. Can we see it?
Barely.
Barely, yeah. Went.
I mean,
So I will do that and I'll put it there in the canvas.
awesome.
So it's easy, very easy problem.